Dear students, welcome to our class on why the winters are cold. I have taken this video at 41.3 degrees north latitude, 105.59 degrees west longitude, at an altitude of 2200 meters above mean sea level. The location is Laramie, Wyoming State, USA. Now, why the winters are cold? This is what I am going to discuss with you. Why the winters are cold happens due to two important things. Number one, Earth. Number two, Sun. Otherwise, number one, Sun. Number two is Earth. See, in the southern hemisphere, the seasons are opposite of northern hemisphere. Say, for example, today, okay, the 31st January, when I have taken this one, it is winter here. Exactly, it is summer in Australia. Okay, so why it is so? It is just because uh, the southern hemisphere and northern hemisphere, these are almost half of the globe. Now, understanding how seasons work in different hemispheres helps us explain a common misconception. It is usually a misconception how the seasons are formed. Many people incorrectly think that the earth is farther and farther away from the sun in winter, therefore making the winters colder. It's not, it's not the case. If seasons were determined by the distance of the sun, that is the heat source. Sun is the heat source. So, if the distance of the sun is determining the seasons, then southern hemisphere and northern hemisphere should have the same seasons at the same time. Today on January 31st, it is very cold here. It is warm, it is summer in the Australian, of course, Oceania area. Now, instead, the seasons are explained by the tilt of the earth. Now you are seeing how much snow is there. So much of sunlight is there. VIBGYOR in that 0.4 to 0.7 microns, it is falling till it is so much draped. The land is okay, blanketed by snow. Why? That reason I will tell after 1 minute. Now, our planet sits at 23.5 degrees angle in space. So, what happens is, as the Earth travels around the Sun in 365 days journey, some parts of the surface point directly at the Sun. Some parts of the some parts of the surface of the Earth point directly at the Sun. Okay, and at different times, different parts of the earth are exposed directly to the sun. Now, for example, in the I am taking this from Laramie, where I said the latitude, longitude, altitude. Now, in the northern hemisphere, today it is pointed towards the sun. Say, for example, the sun hits more directly and warms up this part of the earth. It's not the case today. The sun is getting warmed up more. The sun is getting the earth warmed up more in Australia rather than in USA right now. Now, see, again, I would like to tell you that in the northern hemisphere, okay, when the sun hits more directly, it warms up most of the earth in the northern hemisphere and vice versa. In the winter, in the northern hemisphere is pointed away from the sun slightly. Is it? In the winter. Now, today, this is the winter season here. Here, what is happening is okay, the we are in the northern hemisphere. Okay, it is pointed away from the sun slightly, and the sun's rays come out at an angle and has less of an impact. Sun's rays are not directly falling right over here. So that's why it is uh, winter here and it is cold here. Blanket of snow, we are seeing it. Now, more interestingly, I would like to share with you. Now, you are seeing the blanket of the snow here. The usually, the snow has a high reflective. When the sunrays are falling on this particular snow, the snow reflects. That means snow has a high albedo values. The ratio difference between the difference between the reflected to the incident radiation is known as albedo. Snow has 95% of the albedo. What exactly does it mean? Whatever the energy that is falling on this snow, blanket of snow, is getting reflected, so that there is no energy for melting of the snow in spite of very bright okay VIB war is there. Most of it is reflected. Now another important thing is the temperature difference. If you take the poles, usually if the temperature difference from the pole to the equator depends upon the sun's energy and the energy retained in the earth's systems. Let us take two extremes, equator and poles. The equator receives more and more direct sunlight, and therefore most of the energy is falling on the equator. Exactly. Okay. In contrast, let us take another example. Okay. Say in the poles, the sun's rays are not directly falling. So the sun's rays have to pass through the atmosphere a longer distance. Elevation and weather patterns like thunderstorms also influence the, of course, temperature at the equator. Now, the curvature of the Earth causes the sun's energy to spread out over larger areas with increasing latitude. What exactly does it mean? This is a statement which I say to my PG students several times. What exactly is it? The curvature of the Earth causes the sun's energy to spread out over larger areas with increasing latitude. That means, equator is 0 degrees latitude. Okay. Now, if I am in the northern hemisphere, say at 41.3 degrees latitude, northern hemisphere. Right now, I am standing here. Now, what is happening here? The curvature of the Earth causes the sun's energy to spread. What exactly does it mean? Sun's rays fall directly on the equator. Now, I am standing at 41.3 degrees north latitude. So, as the latitude is increasing, okay, the energy is spread, more and more spread. Okay, the greater the land area, the energy spreads across the lower the energy per unit area. So where I am standing at 41.3 degrees latitude, energy is less. Now you are able to see my shadow also here. Now you are able to see my shadow also here. So that much of solar energy is there. Another thing is the greater the land area, the energy spreads across, the lower the energy per unit area. Now, ultimately, the temperature in an area depends on the amount of sun's energy reaching the surface in that area. The amount of solar energy in a given area is greater at the equator than an equal area at the poles, which is why the equator temperature is warmer than the polar temperatures. Now, a very interesting thing I would like to tell. See, take a torchlight. That's what we call it as the, okay. Of course, torchlights, two batteries will be there, a bulb will be there. Take a torchlight, put directly, okay, upside, take it upside down, lit it directly, and then put it in an angular way. When you are putting directly, more intensity light is there. When you are putting it angularly, the light is spread. Similar thing is happening where I am standing right now. You are able to see my shadow also here. Okay. Now, see, very interesting thing is when you are putting the torchlight straight. Okay, that means upright down without any angle, straight. That means on the equator you are getting so much of heat energy. So much of energy is there when you just slantily 1 degree, 2 degrees, 3, 4, 5, 6, 7, up to 41 degrees where I am standing right now. Okay, so that light spreads, from the torchlight. So that is not so intensity as compared to when I keep directly on the okay no, directly on the spot. Here, I would like to share another important thing here. Very, very, very interesting point here. What is that? See, the temperature right now where I am standing is minus 5 degrees centigrade. Temperature is minus 5 degrees centigrade. The elevation is 2200 meters. That's what I told. As the height increases, the temperature goes on decreasing. That's what we call it as the adiabatic lapse rate. So, adiabatic lapse rate for every 1 kilometer, 10 degrees centigrade is there. Less for 2200, almost when it is a dry adiabatic. Even even if we take average adiabatic lapse rate as compared to the plain area, okay, you are seeing the birds also here at minus 5 degrees centigrade. You are seeing the birds. Okay, you see how the birds are able to manage it even minus 5 degrees centigrade. So it is because the light part is there, temperature is minus, but the wind is dry here. So therefore, the birds are able to comfortably flow. They are floating over the water here. You see that the birds are floating over the water. So this is what I would like to share with you. This is the reason why the winters are cold. Is they are away from the source of the heat, that is from the sun, in a slanty way. Where I am standing is 41.3 degrees latitude. Thanking you, thanking you, thanking you.